This is a quick introduction to the Fondant Normals tools add-on. Install it in the typical manner from the zip file. Once installed, it will show up in the Fondant Tools tab of the end panel in the 3D viewport. The add-on operates on mesh objects that have been added in this list. Hitting the plus button will add the selected object. If nothing is selected, it will add an empty field where you can select an object, or you can use the eyedropper tool. Once the object is in the list, select it there and hit the Add Normals modifier. This will import the geometry nodes group into the file if it is not already there, and then add it as a modifier to the object selected in the list. So we must select each one and add them one at a time for now, but we'll be adding options to add to everything in the future. Defaults to inverted area weights and a smooth iteration. If we look at our normals in the material, we can already see there are custom normals on the mesh. This is because Preview Custom Normals is enabled. The Custom Normals preview is only a preview. It does not currently work in edit mode or on full F12 renders, but that's coming in a future update. You can also see that it's not actually set anything on the mesh. This is a preview on the evaluated mesh only, where it is writing the custom normal to the version that has already had the modifier evaluated. This is because the geometry nodes modifier actually creates the normals as an attribute, and you can use those directly in your shader if you prefer. Just make sure you put them through a normalize node. This is because there is no option until 4.5 to have geometry nodes set custom normals. So we're doing it with Python as a preview. In order to get the normals on the mesh, you use the Set Custom Normals from Attribute button. This will disable the modifier by default, but if you check Remove Modifier after setting, it will delete it entirely. Now there is actually a custom split normals data layer, and it works in edit mode and on full render because it's a typical system. By the GeoNodes modifier in the typical way, it will not set the custom normals. It will add the attribute here so they can still be accessed from geometry nodes, but they won't be updated anymore. In a future version, we will make it so that it does have the option to set when applying the modifier. It's this way because the modifier must deal with all the problems that can arise from having other modifiers on the mesh that change it. Since the amount of vertices and faces has changed, if you apply this, you're not going to get the right result. We have handling for some of those modifiers. If manage subsurf/solidify is checked here, then when setting the custom normals, these will be automatically disabled. Then the normals will be set. Then they'll be automatically re-enabled, and use custom normals will be checked on subdivision. However, you do not need to worry about the usual problems of applying modifiers to meshes with shape keys. Since our set custom normals from attribute command just writes the normals with Python, it bypasses the system entirely. So there's no need to delete shape keys and then transfer them back or any of that nonsense. Now the options on the modifier. Apply object transforms is not set by default. That is because when using the Preview Custom Normal system, that system already handles setting the object transforms. But if you are using this from the geometry nodes attribute, then they won't be there unless you check this box to actually apply them in the nodes. Next are the geometry options. The mesh is always triangulated to calculate these normals or use Laplacian smooth. You also have various options for splitting edges based on sharps or angles, or welding them if your mesh is already split. These all work exactly like the typical options on their modifiers. But note, all of these geometry changes happen on a copy of the mesh under the hood. They will not actually change your mesh. The Weighted Normals tab has options for the normal calculation. These default to inverted area weights, which compensates for differences on mesh surfaces. The factor mixes them back to the default vertex normals, calculated the regular way. If you uncheck this, then you will have non-inverted area weights, which work the same as Blender's regular weighted normals modifier. Note that using area weights of either type can have unintended consequences on low poly meshes. For example, we're seeing here that Suzanne's eyes have become, well, this color, which really denotes pointing more this direction. This is because The inverted area weights have increased the influence of these faces that are pointing backwards, and now that is getting blended onto these. The inverted area weights make these small faces count for just as much as these large faces when calculating these vertex normals, whereas the inverse will definitely get rid of that problem because it is decreasing the weight of these small faces. Next, we have the Laplacian smooth itself. The number of iterations is the number of iterations. It can be scrubbed up to a max set in the modifier. This is set because this can get really slow on big meshes, and you can accidentally scrub up to a very high number quickly. The iteration strength is the factor per iteration, and the smooth mix factor mixes back to the original normals before any smoothing. At first, these may appear to do the same thing, but each iteration actually has a diminishing return and does less. So they are slightly different, and you may want to have a weaker iteration strength and then still use the mix factor to mask certain areas entirely. Note that both these smooth facts and the options in the weighted normal section can be set from vertex groups, vertex colors, or any geometry nodes attribute if you hit this button and then select it. So you can use a vertex-based mask or a face or face corner-based mask if you want it to be different on either side of an edge. The debug section lets you check for problems. Show as position will smooth the position instead of the normals with Laplacian smooth. This can be used to check for any instability issues. In some meshes, there can be problems and you'll have some points like fly off as a huge spike. So if your normals look a bit odd, hit this and see if the mesh is doing something very strange. Show as position also lets us see the actual under the hood mesh. So you can see the triangulation and any edge splitting, welding, etc. Lastly, visualize normals gives us the usual display of lines matching the normal direction. So now we can better see what all of our stuff is actually doing. Scale, adjust their length. That's everything for now. You can read the documentation for more info and more of an explanation of what's going on under the hood. And there are many more features planned already.